This presentation will orient you to defining a facing strategy using Autodesk Inventor HSM Pro CAM software. A common milling sequence begins with a facing operation to remove material from the stock. Ideally, a lot of material is removed quickly, so a large diameter mill is more efficient than a small diameter mill. A comparison to help understand this is a landscaping operation, where a lawnmower removes a lot of grass efficiently compared to using a trimmer. Navigate to the folder that you created to keep all of your files conveniently in one location. Open a 3D CAD model of a part, select the View tab, select the Visual Style drop-down, select Shaded with Edges. Notice that the part features are more easily seen. Select the CAM tab. Select Tool Isometric in the Orientation panel to orient the part so that the Z-axis is vertical. Now set up the machining strategy. The Job panel on the ribbon is used to define properties for machining. Select Setup under the Job panel. A setup defines a number of general properties for a set of machining operations. Each time that a stock is secured for machining, it is a new setup. Select the operation type to be milling. Under the Work Coordinate System, select Model Orientation if the part was modeled with the Z-axis aligned with the features to be machined. This will assign the X, Y, and Z axes in the same orientation for the CAM setup and the 3D model. Under Origin, select the stock box point. This option is used because the stock is a larger dimension than the final part. This means that the reference point must be a point on the stock, since a reference point on the final part would be somewhere inaccessible inside of the stock. Select the top, front, left corner of the stock for this example. We are now ready to define the stock. If you selected OK after entering information in the Setup tab, then double-click on Setup to open the options. Select the Stock tab. If needed, expand the CAM browser by selecting the right edge and dragging to resize it. Use a relative size box option. There are several options under the stock offset mode. Select the Add Stock to Sides and Top Bottom. This option provides a simple way to add stock to the finished part dimensions to represent the dimensions of the stock to be machined. This presentation series will show a facing strategy applied to the top surface. The same can be applied to other surfaces if needed. Change the side offset to 0 inches, since this stock dimension and final part dimension in this example are the same. Change the top offset to be 0.125 inch or 1/8 of an inch so that the stock has a 1/8 inch thick top surface to be removed using a facing strategy. Leave the bottom offset to be 0. Notice that the dimensions are automatically updated based on the offset values. These values cannot be changed by clicking any of the fields. Select the Post Process tab to customize the code generated for the CNC machine. Enter a meaningful title, such as your name and a reference to the activity or project to identify your code. Select OK to save the values you entered. Continue developing the habit of saving your work frequently. Navigate to the 2D Milling panel and then select Face. This will open the Face dialog box. The first tab is Tool. Click Tool and then the Tool Library. Click the largest end mill available to remove material efficiently. This example shows a 1/2 inch end mill. Click Select. There are many parameters that can be adjusted from default values to optimize the operation. The most important parameters needed for a facing operation are shown in this presentation. The remaining parameters will be left as default values. Some of these parameters will be discussed later with the strategies which these should be considered for adjustment. The parameter values presented in this instructional series is appropriate for a learning environment using a light-duty machine. These may differ from values which are appropriate for industry, where experienced operators and heavy-duty machines are used. Explore the help and tutorials for more information to adjust these parameters for unique conditions. The next tab, Geometry, is where the stock to be removed is defined. The stock selection is enabled. The top face of what was modeled is automatically selected. Another feature can be selected if needed. The next tab, Heights, contains information about the Z-axis planes. Expand each field and hover over the feature reference to learn more about each value. Use the default values for the clearance, retract, and feed height. The top height describes the highest cut. Use the automatically generated value of stock top and 0-inch offset. The bottom height is the lowest depth that the tool descends into the stock. Change this to be stock top and change the offset to be negative 0.125 inch. This will allow more flexibility to adjust if needed. The next tab, Passes, contains information about the tool movement. Use the default values for tolerance, pass direction, and pass extension. The step over defines the horizontal distance between each of the passes. A small step over means that less load will be applied to the cutting hardware. However, less stock will be removed with each pass. A large step over means that more load will be applied to the cutting hardware and more stock will be removed with each pass. The step over is measured as a linear distance and can be a value up to the diameter of the cutting tool. By default, step over is calculated to be 95% of the tool cutter diameter minus the tool corner radius. This means that 5% of the cutter diameter will overlap the previous pass, resulting in a more efficient stock removal than 0%. A more conservative 50% is recommended to extend tool and machine service life. A 50% step over for this half-inch tool is 0.25 inches. Enter this value in the step over field. The direction drop-down default is both ways, which will use conventional and climb milling. Conventional milling is when the milling tool advances through the material so that the cutting flutes engage the material at 0 thickness and increase to maximum thickness. Climb milling is when the milling tool advances through the material so that the cutting flutes engage the material at maximum thickness and then decrease to 0 thickness. A way to think of climb milling is that the tool rotation looks like the tool is climbing out of the tool path. There are advantages and disadvantages with each milling direction. Conventional milling has more disadvantages than climb milling, so it is typically used with manual mills and roughing operations. Climb milling has more advantages than conventional milling when using a CNC mill and for a finishing operation. The stock that you will cut is relatively soft compared to metal, so the conventional and climb milling direction can both be used to increase the cutting efficiency without experiencing a noticeable advantage or disadvantage of either direction. For this reason, the both ways option should be used. Leave the multiple depths and stock to leave options unchecked. The last tab is linking. The default values will be used for the facing strategy. Select OK to save the information. The toolpath is calculated and displayed on the stock. Continue to form the habit of saving your work frequently. Select Simulate on the ribbon to display the animation settings. The Display tab provides several options to customize the simulation display. Select the stock option to display the stock as it is removed during the simulation. Use the animation control to pause, go forward, rewind, or change the simulation speed. The Info tab displays machining values during the simulation and is helpful for analyzing machining strategies. The Statistics tab contains several values related to the machining operation or multiple operations selected. Statistics such as machining time are valuable for scheduling the use of a physical mill. Select Close and then select Save. The facing strategy is now defined. The setup and facing operation can be modified by double-clicking to display the parameters of either. This will remove material from the stock to prepare for the next machining strategies to create the final part features. Continue on to the next presentation in this instructional series.